Welcome, everybody. We're going to go ahead and start tonight's meetup. So we are a local chapter of the ACM, or Association of Computing Machinery. That's a professional society of computer science. So I've been inviting AI and data science speakers for this group since about 2008, and our chapter has been going since about 1957. So tonight's talk is Label Deductive Systems for Logical Validation of LLM Output. I was able to catch Boris as a speaker while he's in country, so he'll be leaving Friday. So Professor Boris Galitsky has about 25 years of experience. So for a little bit of background, we're a nonprofit 501c3 oriented at promoting knowledge of modern computing. We also do other events. In March, we just finished reviewing 1,000 science fair projects and awarding first, second, third projects for computing component for 6th graders to 12th graders. And it's really amazing how well some of the top student projects are. In fact, we'll have one of them as a speaker next week. I'll have their title coming up. So we have a meetup with about 13,000 people that have come to our talks in the past. And we have about 180 or 200, I haven't counted lately, recordings or presentations of our more recent talks that we've had. We have a honor system jar for the or plastic box in the back. Being a nonprofit, the $20 annual membership doesn't quite cover the food for everybody, so we invite the contribute. We have a couple of sponsors. One sponsor is this building location, the Valley Research Park, VRP. They rent suites and cubes and access to meeting rooms and stuff here. So that's part of their business model. There's also RXM. They have cloud native and AI training and consulting. So say if your company wants to have a week-long custom Kubernetes training class for your staff on site, then they could travel and host that. Another sponsor is Front Egg. They have an out-of-the-box low-code identity platform. And then C-Cube. I am chief of data science there. We have a couple of products, IntelliConnect, chat with your data, RAG-based product, and also Guardians for guardrails to protect and implement policies. We're just now recently launching on our website some buttons so you can try a demo versions of those. But the demo version is you can load some of your company data in there, and you can share that with a couple of different employees and see that. So a taste test. So while we have 160 people that have signed up for tonight's event, usually 2/3 or 3/4 are remote. And so I'll be monitoring on the computer over there some of their audience questions. For the audience here, if you do have a question, we want to make sure that the microphone can pick up the recording. So either speak at my volume or speak in a short enough question that our humble speaker can repeat it. So if you have a 3-minute context and a 2-part question, he won't be able to remember it. So be kind to our speaker so he can repeat it. Both the remote audience and the later YouTube. We also have a call for volunteers. We have about a dozen volunteers that help organize this and the many different activities we have. There's different ways you can get involved for different skill sets. Yeah, you can start small. Audience announcements. So I'll go from one side of the room to the other. If there's an upcoming meetup or conference that you want to share that's local, or if your company is hiring, then you can give that as an announcement. What's that? Oh, please.
That's the end of the slide. I was going to say, there's a group I co-host that's here from a Thursday, SFBayACM Generative AI.
Okay.
And we meet at Mira over in Lawrence, especially on our guys every Thursday at 7 p.m.
Oh, okay.
See some
What's the name of it again for people?
SFBayACM Generative AI.
SFBayACM Generative AI. Yeah, I think I've attended that once in the fall, and then I got busy with ski season.
Give or take 20 people. It's a pretty
kind of sit around tables and people chat together.
Big long table. We dominate one of the rooms there at the Mira. So
okay, yeah, that's wonderful. Yeah, so that's the kind of thing we like to share because learning is not a zero-sum game. You know, the more ways we can connect with other groups, the better.
Yeah, it's good. Yeah, it's good. I go to that.
Okay, excellent. Well, thank you for that. Some upcoming ACM events. Oh, yes.
Also would like to have
oh, please.
So Basically, we just launched our app, and then we are also recruiting some like
Here's a microphone.
we're also recruiting some tutor. So, my name is Xavier. I'm a founder of ID. We just built an ID called Linko. It's basically allowing you to build any iOS app, Android app, like in minutes. So it's a vibe coding tool basically, and then we're recruiting tutor, like people who can like use it very like efficiently, productively, and then video record it. And we want to like basically like develop our social media stuff.
Repeat the name. Like, what do people search for to find it?
Linko, Lingcode
Okay.
dev.
Okay.
Linko dev. Yes.
Okay.
On Apple Store. On App Store and also on website. Yeah.
Oh, excellent.
So yeah. So if you are, interested in like teaching, vibe coding, and get people to learn how to vibe code, let's talk. Thank you.
Okay.
Can you spell the website again? Lingcode, Linkcode.dev.
There's a whiteboard. Maybe afterwards you can just write it on the whiteboard. There's probably markers on the far left side in a tray, and just write in 1-foot font. Sometimes people tend to write what's naturally small. Okay, so upcoming events in May. So that'll be here at VRP. We have Closing the Loop, using computer vision to auto PCB e-waste sorting. So this is a student project from the science fair. And we hadn't yet voted on who the winners were, but I was just talking to those students and liked the project. They have computer vision and robotics to go over. You place an arbitrary PCB board down, and it's heated up on a hot plate with salt, so better conducts to melt all the solder. And then the vision recognition goes over and identifies things that might be useful to pick out. So hello? Maybe a low battery? Well, I have a loud voice, I can continue without. So that's next month. So we'll have 3 speakers. They're from juniors at Archbishop Mitty High School. June will be to be announced, but I think we have a candidate speaker over here. And then in July, we have multi-agent systems at scale as a shared platform for enterprises. So we have some good content coming up that we hope you'll like. Now to introduce tonight's speaker, label deductive systems for logical validation of LLM output. So LLMs can generate hallucinations, known problem. What to do about it? So he's proposing a hallucination detection framework. So he's got this valid LLP for LLM. It's based on labeled logic programming, or LLP. Some of the components, and he'll tell you more details later, involves logic program, argumentation, probabilistic inference, abductive explanation, symbolic rules that are annotated with semantic, epistemic, and context labels, and applies discourse-aware weighting. So it's not just a off the top of the cuff, let's crank out something in an afternoon. And as far as Boris's background, he's contributed for linguistic and ML to Silicon Valley startups, as well as companies like eBay and Oracle for over 25 years. He has contributed to a number of acquisitions, companies that Yahoo acquired, Groupon, Tibco, eBay, and Symantec had acquired. So he understands the startup lifecycle. He's now a lead researcher at Moscow Institute for Physics and Technology in Russia, and his LinkedIn profile is there. So please help me with a warm round of applause for Boris.
Quick question. These slides,
The slides will be posted on the meetup site for this event. So if you scroll down to the bottom after the talk description, there's a comment section, and Boris offered to post the link to the PDF. Oh, and then also I forgot there's a hook. I need that hook back. You said 5 seconds. So this is A book that Boris recently published, Healthcare Applications of Neurosymbolic Artificial Intelligence. And he's offered to share a link to the PDF of this at the same site on the meetup section. So I'm going to download this. But this is also some good content. If you'd like to look at it at some point after the talk, you're welcome.
Good evening.
So take it away.
We will talk about logic today. The disadvantage of logic is that we have to confess it lost. For 50 years, like starting from 60, for 60 years, there was a very strong competition between like logical artificial intelligence and neural artificial intelligence. And we logicians, we lost. Okay? We lost, but there's still some issues in a neural network, in language models we can help. And part of it is validation. Again, disadvantage of logic is that it's hard to cover everything. Like we have one ChatGPT and we can talk about anything. And we can have one simple logic and it can cover like elevator buttons or like very specific behavior, particular bird, very, very narrow. They said for 50 years, logicians try to convince the world that like you can formalize in 5 axioms something like behavior of a bird, and then from that you can proceed, just give us few million and we can proceed to like reasoning about the whole world. A lot of money spent, never happened. So logicians overpromised and under-delivered, and I should say, but neural network, and I'm on the logician side. For many years, I was on logician side, not on neural network side.
I was always on the neural net side, so we've been in these debates.
For many years. So again, impressive results in large language models. However, integration into serious domains, structured, verifiable, context sensitive, still problems. Associative rather than strategic reasoning, problem, a limitation with multi-step, revising, problem with revision, and a main thing, hallucinations. Like in my personal life, asking about, I don't know, taxes, travel, you never know, you can never fully trust, right? So that's the main purpose. So the advantage of logic, it's a tiny, it can cover tiny bit, but like today, I'm interested in registering my car. I only need logic about very specific, just 5 axioms. And ChatGPT actually gave me totally wrong answer. I wasn't able to register my car according to what ChatGPT said. And if I have used logic, any kind of logic, I wouldn't trust it. I would do it differently. So logic still can help. So LLMs can be coupled with external reasoning and verification layer, enforce logical consistency and explanation. Again, why? Today I will try to explain a special way of logic in a universal way. Again, logic is limited. It's not what we use every day, but the main advantage, like we use LLMs day and night, but nobody fully understands how they work, right? And the advantage of logic today, I will try to exactly explain how universal logics work, reasoning about anything. Again, at this current, I mean, fixed part, you can only reason very narrow, a very small, narrow domain. But in general, I will explain how logical reasoning works. Today, there's a big mixture between like inference of LLM and logical inference. It's also important to understand that real inference is logical inference. LLM inference, you get result, but at the end of the day, you never know how it arrived to that result and what actually happened. And in logics, we do. So that helps us with trust. So validation, explain what system name valid LLP for LLM. Label logic program. Label logic program, it's my version of a label deductive system, and I explain the difference. Discourse is very important. I will explain what is discourse in linguistics and how it can be used to be logical representation. We'll see how logic works, a label logic program. briefly run through evaluation, just mention what I'm evaluating here. And then let's look at the problem other way around. Sometimes LLM hallucinations, if taken creatively, can lead to inventions. So most of times hallucinations are bad, but sometimes they're useful, and we'll look at examples. And we look how abductive logic works and how it helps human and hallucinating LLM together inventing something. And finally, we'll talk about applications. Neurosymbolic, it's a hybrid. The idea of neurosymbolic, neural is like large language model, like ChatGPT. Symbolic is whatever logical system we build. Again, what is discourse? We have syntactic level, semantic level, and discourse level. Syntactic level is rules based on words, how words come together and form sentences. Semantic is about meaning, how words come together and form meaning. And discourse is high level, how writing author organize her thoughts, the structure of thoughts. And the important thing of discourse is domain independent. That's exactly what we need for logic. So discourse helps us to have a higher level abstract view on text and then leverage it to formalize. And I will show examples. What we need to know about discourse, that each text, each paragraph can be split into parts, which calls nucleus and satellite. Usually nucleus are more important and satellite are dependent and only meaningful in context of nucleus. And the knowledge of this organization of text tells us how we logically represent. Because we have logical terms, we have probabilities, and reliability of satellites are always better than nucleus. We will look at examples. Now, the research I'm competing with. What's popular approach today? Like we have particular problem, a particular question, medical question, legal question. We ask ChatGPT. So for ChatGPT, it doesn't matter. It learned from huge corpus. It doesn't matter which domain. For reasoning, it's important. Is it reasoning about time? Is it reasoning about space? Is it reasoning about financial transaction, physical transaction, chemical process? It's all these all have different logic. These reasoning domains are all different. So typical approach today, we first train LLM to pre-recognize. Okay, here is a question like a legal question, a small claim court. Then it's important. The importance is time. Which documents submitted after which. Then we have axioms about time. So the system first, first you send it to ChatGPT, do nothing, ChatGPT gives answer or another one. Then you need to figure out which logic to use. We need to look, the system looks at text and decides, okay, this is about time, this is about modalities, this is about probabilities, this is about chances, this is about like a dispute, this is about argumentation. So, and then for each domain, there's a special solver. So first I design logic, reasoning about time, then reasoning about space, then reasoning about argument. The disadvantage of this is that this recognizer can misrecognize, and then the whole system breaks. The whole system means we want a logical verification, logical support of ChatGPT. Fails means we don't get any support. So we still don't know, trust or not. So how it works? We're trying our best to confirm the result. If we independently, logically, outside of LLM confirmed it, then it's very good. Definitely we can trust, because two totally different paths. And our logical inference is totally transparent. We can fully trust it. If we cannot confirm, it doesn't mean that ChatGPT lying. But it isn't confirmed, so we don't know if we can trust or not. So we do our best to confirm. But if we first trying to recognize domain, which reasoning domain it is, time, space, modalities, and we make mistakes or we don't cover all domains, basically we cannot verify. Again, we cannot verify. It means GPT result stays, but it's unconfirmed. We don't know if we can trust. So instead, our approach, we don't make a dependent correct classification, and we make unlimited coverage, because if we have one logic program working for all cases, then it's and we can prove that it can cover all possible reasoning patterns. Again, there are a million domains. Knowledge of life is unlimited, million domains. But reason domains are still limited. We're talking about 10, 20, right? It's limited. But still we have to formally encode each. And then what is important, this is to better understand how logic works. We have logical axioms and domain-specific axioms. We studied geometry in school. We studied geometry, we studied axioms about lines and points. How we infer rules of inference, it's about logical part. The knowledge about lines and points, it's applied part. So again, applied part is built by ChatGPT when we do it. So it's infinite. But the logical inference type, it's limited. So that part we have to recognize and pre-program. For this system to work, we have to program one way or another reasoning patterns, how we do inference. And again, it is limited. Again, word knowledge is unlimited, and programming patterns for reasoning is limited. So we do it once for all. That's the idea. Just to repeat, on the left, I'm showing traditional approach, domain pre-recognition, and on the right, our approach based on label logic program. Labeled means I have one program for all, but just different axioms for time are labeled as time, axioms for space is labeled as space, axioms for modalities, for argumentation are labeled accordingly. We will see examples. Now let's switch gear discourse again. We have examples. Again, we have nucleus and satellite. Let's take example of review. Like we analyzing reviews. My camera has good battery life according to my friend who used it from time to time. I have two parts. First about camera, and then about attribution, where I got this information. So first part, nucleus, is very important. That's the key. That the camera has long battery life. And the second part, according to somebody told me, that's secondary. And basically, that's not important. So when we logically encode text, we have to do it accordingly. And what is important, classical logic, like what we study geometry, for example, or algebra in school, they're always strict rules. Like lines and dots, always strict relationship. In real life, a relationship can be defeasible. And in my example, a camera with long battery life, that's the fact. It always holds. I mean, from this sentence, it means this camera is such, the battery is such and such. But according how I get it, I read it, I heard about it, somebody mentioned, my friend sent me, told me on Facebook, that's secondary, and that can be defeated. So for example, maybe I lie about the source, but the main statement is true. And that is very important when we encode text with logical rules. So we have for nucleus, we have strict rules, for satellite, we have defeasible rules. And then any text. One sentence can be split in my example, paragraph can be split, and this can be organized as a tree called discourse tree. So the whole long text is organized into pieces: important, unimportant, important, unimportant, satellite, nucleus, nucleus, satellite. Nucleus is strict, satellite is defeasible. Defeasible means if there is no evidence, we can trust it. If there is evidence against it, it can be basically, it's not true. And this is very important when we encode text. So discourse, because it is domain independent, is important when we encode text with logical rules. Now, easy question. Take a guess. Yes.
So, for example, if you have the nucleus is a cup,
Yeah.
then the state could be the cup is on the table.
Cup is on the table is nucleus.
That would be a defeasible fact. But then if she can't see the cup on the table, she might report, "Oh, I don't see the cup on the table." So you could have countermanding.
Okay. Let's consider this example.
From different sources.
Yeah, I will. So the cup is on the table because one person next to me saw it there. Cup is on the table is observable fact, so it's a nucleus, and somebody possibly saw it or maybe not seeing it. That is satellite. So satellite can be defeated. One person saw, another person didn't see. And here is the cup, here is the table. That is strict, not defeasible. So two parts of the sentence. And this is a way. Yes.
How do you not on your design logic?
Okay. So now a very good question. How to design a logic rule? Who can give a hint? Very easy answer. So basically, large language models does everything except logical reasoning itself. So today, ChatGPT is pretty good. We give it a label logic program and ask, now you answer me about registering your car, now represent this information in this logical programming format, and it does it. So again, almost everything is done by language model. What we do, we organize, orchestrate it, and we use logic programming environment to run logic program. Again, today we don't have to. 10 years ago, there's no way. That was totally unsolved problem. How to take in text, represent it as a logic program. Not possible, just not possible. Very buggy, very noisy. Today, language model, in addition to answering questions themselves, they can also help us with logic representations. So again, they do everything for us, other than validating themselves. Okay, so my answer is yes.
So LLMs can be very good at generating code for specific syntax, like
Yes.
JSON or Python or things like that. So do you have it represent internally like a logic rule as something that's expressed in Python or some other syntax?
So LLM can generate in JSON, can generate in Python, but here what I need, instead of Python, I use logic programming prologue. So because I have examples and like language models, large language models already trained from code in logic programming like Prolog. They can also represent in Prolog similarly how they do it in other languages. So that's the easy part. The hard part they represent, but then how to finally run it. So we have to run it. Again, they don't have to do it exactly first time. For example, we can say, first try representation, we run it. It just doesn't run. It's inconsistent. Wrong. ChatGPT did it wrongly. Do it again. Do it 10 times. For example, it's a very important question. It's like medical diagnosis making. We don't mind first asking ChatGPT 100 times and then asking 100 times to answer question and then generate 1,000 logical programming representation, run each till we try to confirm. Because if we confirm, that's a win. Basically, we can trust it. And if it did not confirm, again, we can ask 1,000 times. Sometimes answers coincide, sometimes they're different. How do we know which to trust? This is example of discourse relation. There are logical relations between nucleus and satellite: cause, effect, condition, contrast, elaboration. And there are examples. And also, what's important, and what we learned, and in this study, what's importance relation? For example, for cause, It's a 0.8 and 0.2. Like nucleus is very, very important, and satellite is very less important, very unimportant, and so forth. And we get it from data from some corpus of text. And now let's go to the logic. So some time ago, like 50 years ago, famous logician Gabay suggested trying to resolve conflicts between different logic groups. Basically, logicians came up with different logics and argued which logic is better. And Gabay said, don't argue. Let me define it, a label deductive system as universal thing. And then Gabay showed that everything is the same, just a label. You can vary the label and derive different logic. So it's another level of generalization above logical reasoning. For this work, we implemented it as logic program because we could not, we cannot run whatever formalism Gabay suggested directly. So we need to convert it into something runnable. So instead of a fact like cat is black, which is A, we have now label. A is object level statement like cat is black, and T is structured label. It's a meta information times, source reliability, modality. Cat is black at night, cat is possibly black, cat is black because the dog made him black. So all kind of thing, it all goes to meta level, argumentative role or uncertainty. This is an argument between some people if this cat is black or not. That all goes outside of A. So typical logic is just A, B, C, and then logical connectives, and then predicates with arguments. But here on top of it, we have a label T. Example from medicine, complication, if infection, this is called clause. This is on the left head, and this is a body. We need to satisfy the body, and then we have definition. So logically, it looks fine. But now in clinic, we have some, like infection, we get from electronic health record. Immunosuppressed, we got from blood test. We got something we get from patient complaint. Something we get from previous history. How to combine this whole thing? And by the way, that's a very typical example where language model fails because it doesn't have systematic way to treat different sources. Some sources are more reliable, some sources are less reliable. And like ChatGPT doesn't have any reason to treat different parts differently, but we can because we have this logic. Different parts come with different labels. And again, label can be like we're trying to make diagnosis. We have features, but not all features are equal. They come from different sources, and they're noisy, and the nature of noise is different. So now formally, let's go a bit more formal. So we have set of label logic program is a for tuple, labeled facts, algebra, how label are compatible, how we propagate label. Again, for example, we have incoming information to make a diagnosis. We have, again, different sources, different trust to parts of the different assigned probability and reliability, and how are we going to combine this? And this is called labeling discipline, how labels introduced, transformed, and combined. And then we still have different inference ways. So for this system, we can take off the shelf different reasoning systems and implement them as logic program. How inference rule looks. This is a H holds if B1 and B2 and B3 and Bn. Then for each B, we have a label. So think of this rule again as a diagnosis. We have we have COVID, if we have high temperature, we have coughing, we have fever, we have headaches. But different of these features, again, come from different sources. They are very different by nature. We cannot just combine them as an end. So large language model takes huge statistics of text. But maybe in given hospital, everybody gets COVID for whatever, because of very specific. And ChatGPT doesn't know about. If we use a RAG approach, we have like notes from this particular hospital. ChatGPT doesn't know what's more important, like pre-learned knowledge from the whole web, or just this document, how to combine. There's no systematic way. It does it statistically, not systematically, right? Just averaging. But this is what I'm explaining. We take different features and have label for each feature. And then there's a specific clear logic, step by step. We know which illness feature, how to make diagnosis, which illness feature, we know how to treat, we know how to, which label to apply. I think maybe I stop because that's like essential part. Stop for questions and for thoughts.
I think you're from the book is about it, so
Okay.
I look at it. So you get a lot of guidelines. You shall not do that. You shall not do that. Okay, it's like they suggest FDA.
Okay.
Suggestion is a mandatory thing.
Okay.
You can translate all those essentially guidelines into actual rules.
Okay, so question is how can, if it's possible to translate regulations into the rule? And the short answer is yes. But my other question now, how can you encode this in ChatGPT? You either learn from the web or you give it a document for RAG. So, okay, you can give it a document with regulations, but how do you know which way it digested? It does it averaging, using averaging and probabilistically. But here, using this approach, you actually can verify that each rule is coded exactly. For example, regulation is telling you, like temperature, you only use like early morning or late evening, but pressure, you do it at the time of like doctor visit. This, in this way, you just explicitly encode it using labels. And for language model, you just throw text on it. It will learn from it. It already knows a huge amount of similar, but how do you know that it will follow exactly this? That's my question to you now. How do you know that using large language model, you have this exact exact steps as in regulations? How can you control it?
So no, I have run into these problems.
Okay.
So I know that this was the missing part, and that's why I'm attending the talk.
Okay. So basically, you're confirming that that large language models are smart in general, but it cannot be verified with respect to exact sequence how you handle each type of data by this exact standard. And using this rule, it tells you how exactly, again, how we use blood test, how we use pressure, how you use temperature, when, and you can make sure that you can encode it, regulations exactly.
Can you also flag which rules got broken?
Okay, so then you run the program. Then if it doesn't come to an end, it means that there's some inconsistency. It means some represent. It might mean that the question is inconsistent, and a large language model should refuse any answer. It should explain that it's consistent. But you know, sometimes it does it, but in a lot of cases, that's typical hallucination. When there's an easy question, like I have a bad cold, whatever, no hallucination. But if you have inconsistency, then because our language model are trained in general case to satisfy the user, in particular case, it trying again to satisfy and fails. Here's the question.
If you have multiple rules that chain together, like
Okay.
in Go
Okay.
that could be like a graph segment, where you have graph nodes, you have relationships that could be attributes.
Okay.
You know, cup could be one noun, table could be another noun.
Okay.
On the table,
Okay.
on it could be an edge.
Okay.
So if you have your rule set, that could also be related as a graph.
Mm-hmm.
It sounds like you're not using a graph data structure in the back end. Are there pros and cons?
Okay.
Why?
Okay.
Why not use the graph? Why would a graph help?
Okay, graph is not as expressive way of representation as a label logic program. And that comes from the time of Gabay, that comes from the language of graph representation, just a regular graph, is nodes and edges. It's not as you cannot express everything you can express in graph, you can express in logic, but not the other way around.
And so that a given node could have a dozen attributes. A node could be like a structured record, where a structured record could have 10 fields that are different attributes for that one record at one.
So in this respect, I follow Gabay, who proved that this graph language and logical language. If you have, for example, like propositional calculus and first order, then you can compare. There are formal theorems comparing like how you define graph, because graph can also be multi-edge. You can introduce some complexities.
Yeah.
A simple way of thinking of it, that yes, simple answer is yes, you can represent it as a graph. But if you go into details, we'll run into some problems. So again, simple way to look at it, yes, you can.
Over a strict graph representation.
Yeah, so short answer, yes, there are some advantages.
Okay.
So not everything you can do in graphs.
So kind of building up of what is asked about, you can have some set of regulations, and those regulations have revisions.
Yes.
And LLT will understand that certain revisions will.
Revision is labeled. Yeah, revision is T in this. Yeah, revision is T.
Yeah. So,
and how do you do revisions in
a graph?
In a graph, it's obvious how you can do revision in a graph, but then tell me how can you do revisions if you train LLM from fine-tune from text?
Right. Yes.
That's probably not possible. Yes.
So I talk a bit of this. I really do appreciate this idea using LLM to build a plot.
Okay. Okay.
There are some interesting questions about when you use logical inference. I'm not actually
okay.
I'm familiar with predicate logics. But the whole program in AI is predicate logics that are having to work with default logics, there's probably more logics on top of that. Produce a very brittle representation.
Okay.
And it probably didn't have to work with statistical inference. It was not a very well managed problem. So you have a rule that says measure the temperature in the morning. Well, it happens to be 9:06 a.m. If you apply the rule or not, then maybe you have a way. An ad hoc way of software. You kind of come into these areas where your uncertainty more powerful.
Okay, so first label. So the question is, first brittleness. Brittleness is obvious limitations of logic, and because of brittleness, a neural network basically a logic lost, and neural networks are winning. In the short answer, but
different alternatives. Go ahead.
Okay, so first, this label logic programming covers probabilistic reasoning. For example, it covers probabilistic logic program. What is probabilistic logic program? You have a clause. Let me come back. You have a clause like this: complication and affection.
Yes, but if you apply certain factors to clauses, and when you try to reason, you end up with inconsistencies. This was a problem that
okay,
so I had a specific safety I don't know.
Yeah, that's a very important question, and let me try to answer. It's a very important question. So first, it doesn't have to be single. So single try. So first I have LLM answer. Then I ask LLM to build the specific ontology just for this case. That's how I solve the brittleness problem. So I never do universal ontologies. Ontologies for this particular case, they're very tiny. So they cover exactly what I need to try to confirm. If I don't confirm, I'll try different ontology. the problem of brittleness is trying to use fixed ontology for all kinds of problems. Then it is brittle. But now I'm saying, try first. If it fails, try second one. But once, if we are lucky, and this ontology worked out and confirmed or reject LLM, that's a win. That's the most important thing. Now we know we can trust or distrust.
Okay. The goal then is to, like, try multiple programs, seeing which ones are valid.
Yeah. So what is not probabilistically possible is to build incorrect ontology and then prove confirm LLM results. That's so much unlikely. That's not realistic. So this probability of that is 0. So like false positives are impossible, because if you with logic, if you confirm LLM, that's huge coincidence. It cannot happen just randomly. So we cannot, if we confirm with logic, then we 100%, okay, 99.
The logic programs.
Yeah. So logic programming cannot be invalid. So if we have two totally different ways and then coincide with the result, we can definitely trust it. That's the main claim. Yes.
Yeah. So I understand the premise, right? Now, can it be part and part? Can most of it be LLM? And can the logic part be offloaded to logic program?
Okay.
Solve this problem?
So how it works? Like I have the like online demo with the tools. I just run OpenAI API. I have LLMs. Then I request OpenAI API to build ontology for me. Then I use SWI prolog to run it within Python. Then I have, if it doesn't run, then I try ChatGPT to build another representation, then build another representation. Then, once it finally successfully runs, again, I ask ChatGPT to compare logic. I'm not doing it because ChatGPT also does that. Compare logical result and its own result. And if they coincide, then it's good and then it's trusted. If they don't, if there's no coincidence, it doesn't mean that, again, ChatGPT is wrong. It's just that we cannot trust it. Okay?
Of course, right? I was thinking this is a logical problem. It can be solved in a logical way. Is that correct?
Okay, so we try to simplify logic program, because one approach would be, let's try to build reasoning system which can reason about anything and answer questions about anything. That's way more difficult. That's not doable. What is doable to build logical representation for this exact problem, one at a time. Because exact problem for all world, we need millions of axioms and representations. For this particular problem, even if it's 5 axioms, ChatGPT can get lost. But 5 axioms, it's either prove or it either confirm or reject. So the problem when we encounter hallucination, logically they are not complicated. That's why, again, brittleness is not a big problem, because we only need those axioms which are used. Again, the main problem in logic, we try to build a logical, if it's a pure logical system without LLM, we have to build a lot of axioms, and then they become inconsistent, and then we update one and break another, and then it becomes unmanageable problem. In this case, I only build logic online. I build a presentation only for this particular question with ChatGPT. That is why it's very small. It's basically just half page, a logic program, half page. And we're not going to get lost in it. But we need to understand that language model can easily get lost and hallucinate for the same problem, because it has all millions of text to arrive to the statement we compare with logic. So this is like most important part of the talk, and it's important that we understand.
So I have a question for you.
Yes.
When you do regulatory compliance,
Okay.
safety parameters, then those are very bad documents. you're saying you want to make subsets.
Okay, so I don't do logical representation for the whole regulation. I only do for given question. I only identify, and not me. I ask LLM to identify parts which are relevant to this question, which usually it does correctly, and then I build small logic program, half page like size, and then run it. So again, if I try to, in advance, to build logical representation for the whole regulation book, it's going to be inconsistent and brittle and not manageable. But if I only on demand do it, what I exactly need for this question, then it's small, and the system basically does inference, and human can track it, and it doesn't get lost.
Well, yes. We've had about 10 minutes of questions. Maybe we can go on for a few more slides before more questions.
Okay, because
or just get through the content.
So this is logic program. We explained, but again, this whole label logic system, it's okay, like 10, 20 page. It's not a big. It's just basically prolog meta interpreter, which operate. I showed formal rules, and it's implemented as a logic program. So what happened in our runtime? We have this part. Then we add what LLM ontology builds for this question. Then we have a representation of the question, like very simple, like diagnosis we saw. So this representation of the question, just a simple clause, right? Just simple. This is a representation of the question. And then it runs. It's instant because it's very small. It runs instantly because it's not a lot of data. And then we get confirmation or rejection. And this is, I repeat, how verification works. We have claim instruction, label assignment. Like label assignment is exactly what you mentioned for regulation. Like again, what we do with temperature, what we do with pressure, what we do with how patient estimates his pain or whatever. Domain rules, multi-profile verification means from point of view of time, argumentation, like for example, multiple physicians argued about diagnosis, probabilistic. Some parameters we can, like if you have blood pressure, we can assign probability. But for given hospital and given disease, we can. And then we have a label verdict. So something is supported, something is defeated with this label, and something is uncertain. Just for compare, that's more for logicians. Before this project, I was actually trying to code individual logic approach. I coded a standard logic program, negation, probabilistic. So I took from different authors different prolog program abduction, argumentation. And then running into all kinds of problems. And before, the approach was I just run each independently. Whatever fails, whatever confirms, that's good. I try 10 different, whatever I get success, I'm happy. If not, then I cannot confirm. And then it turns out, and then in my evaluation, I compare. So this is a screenshot of the tool. It's on my GitHub. We have different tools. Basically, press button, and then you see like argumentation. You input question, ChatGPT runs it, and then builds representation, and then it takes some time. Mostly taking time is ChatGPT building representation because logical inference is instant. It's a very small set. This is example visualization for argumentation. It's also medical domain. Some clauses about two similar diseases, and then we try to separate these diseases. Evaluation, I think we skip. So very brief. We have human evaluation. We predict accuracy with a label symbolic, with a label logic program with discourse, without discourse. We see that discourse helps. We then try different logical components, and then versus label logic program, which is universal and does do some assessment. Then let me move on maybe a few minutes for questions, and then.
Questions can be anytime. I just didn't want to have.
So now I am switching to next part. Again, briefly, hallucination can lead to invention. So some hallucinations are not as bad. Now we're not going to verify them, but we're building abductive logic program on them. Let me go to formal definition. We are inviting a certain chemical process with features. I want to run briefly because that's the most important part we covered. So engineer is asking, can fixed bed catalytic, it's a very domain specific, so I think I should run it quickly. Fixed bed catalytic reactor passively regulate temperature without external control loop. So the idea that if you just have like a chemical process and you like spread catalytic thing through, then some part will overheat, some part reaction will go slow, and it's hard to control. And usually to control it, you use real control, like computer controllers, which regulate temperature. And the question is, can we design it so it's self-controlled? And then LLM gives actually hallucination answer, which is the response hallucinator. It's no oscillatory catalytic feedback mechanism. It doesn't exist. It's invented it. But it turns out that based on this hallucination, you have a model of actually with high activity zone, medium, and low, and then it's distributed so it kind of controls itself. If it's some area overheated, we don't need to measure temperature and then like redistribute some reagents. It happens on its own. So hallucination led to invention. That's a briefly. Hallucinations are not always bad. I think I'll skip formal. So using abductive reasoning, abduction is reasoning by explanation. Can you build explanation for this? And invention can be now defined through hallucination using abduction. They're just there. So hallucination is abduction with lower prior, high constraint risk. So briefly, idea is we let it hallucinate, but then we have multiple mechanisms to filter out. So out of 100 hallucination, 99 going to be useless. They don't obey physics law, they're inconsistent and whatever, but 1 out of 100 turns out to be useful. So that's the idea. And using hallucinating LLM and human working together forms a creative invention machine. I also built a data set of invention in possible inventions chemistry when LLM gives incorrect hallucination answer and try to automatically perform this inference. And then also check different logical steps. But this is now different. It's constraint checker and abductive logic program. Again, abductive logic program, it's a logic program which finds explanations.
Question?
Yes.
So do you have some kind of question classifier that routes through the different kinds of logic? One of your slides, you had a screenshot that looked like 10 different ways of approaching or solving the problem. So do you have something that's like in front of a mixture of experts model, they would say, oh, send this to the history teacher agent, send this to the English teacher agent, send this to the chemistry teacher agent. Domain specific, but you have logic types. So do you have a way of recognizing a particular question? Oh, I'm going to route that to logic type 2 and 4. I mean, just pick some numbers. Is there something like that, or you just run everything?
So what you ask, the question is a mixture of experts.
Yes.
Each expert is a specialist in particular logic. Can I first predetermine which domain, reasoning domain? Is it about space, time, abduction, or modality? So this is a more typical approach. It has been tried. And again, the limitation of it is that if our classification is wrong or particular domain, for example, it's about space and time, then we run into problems. That is why we need universal. And I showed in my evaluation, I compared individual reasoning components like mixture of experts, again, expert in particular reasoning, with universal expert. So it is the conclusion is it is useful to build universal expert in this case, which is a labeled logic program.
So that if you're running, say, all of those,
Yeah,
then they all get answers coming out at the end. Do you get some kind of?
it's more likely, no, most likely in logic, if it were LLMs, yes, but in logic, they mostly fail. Because again, the logic is brittle. If not everything is like totally logical, then it basically fails. So if I have a problem, I run all of them, most of them fail, but whoever did not fail, then I compare with LLM. If they confirm, I'm happy, confirm. If I'm not confirmed, I don't know, but I cannot trust.
No, logic failures are because of
Just inconsistency, just in something not defined, missing externals, missing constraints, missing links, something is missing. For example, if it's reasoning about time and I apply actions reasoning about space, I just don't have enough relations between space. That's why I cannot satisfy this logic program. And if it's both reasoning about space and reasoning about time, and I try either, they can fail just because they have inconsistent. It will like spatial relationship between points in space will be interpreted as relationship between points in time, confusion, inconsistency, no result.
with the system being improved, if things are failing due to lack of constraint or information, and say, did you mean X? Or what is the value for this attribute?
Or there's no interaction. It's not like dialogue between like logical system and human who can help. Unfortunately, this is like all fully automated. So theoretically, I could improve this ontology building, but then it defeats the purpose. Then I don't want this manually. I mean, don't want this to be a manual process. The goal is to automatically verify LLM.
Another question over here.
Yes. Yes.
Yeah, right. I'm pretty
Oh, okay.
so I understand. But I just want to know, are you only verifying after the output? That's it, or you verifying after the output?
Okay, in this respect, I'm only verifying. So first, I'm verifying only after, because there are architectures where neural and symbolic work together. Here, for simplicity, just to make it simple and focus on showing that universal reasoning is the key, I only do verification.
Okay, so
Just for simplicity, because then it will be too much, and then I don't know. Again, this is a very specific study to show that universal logic is a winning. It's basically that's something you need to do. And like repair, you can repair hallucinations. You can go to the web, for example, or you can apply, like try to. This would be different problems. This is different. Okay. Yeah, I've heard about math work. Yeah, theorem proving. Mhm. Okay. Okay. Questions? Okay, let maybe switch to so with hallucination creativity is simple and clear, right? Basically, sometimes they are useful. Let's try to look at practical problem. In July, I was presenting a social promotion system. Somebody.
For the remote audience, perhaps maximize your screen and enlarge the font.
Okay. So this is practical system. Complain very if we have totally practical and explain why hallucinations are important. So if we run into problem in life, like okay, delayed flight, faulty product, bad financial, like I'm not happy with bank customer support. So right now I'm spending time on the phone. I'm writing as a human, writing emails, trying to get call, trying to go to Facebook and talk to the representative. I'm upset. It's taking time. and it is stressful. So the purpose is automated agent, which does all of this automatically on my behalf. I'm just explaining a problem. I'm just explaining a problem. So connect with Gmail. And then I have all kind of complaint, misconnection, flight delay, furniture problem, nurse coming irregular time, rude music teacher, tardy tax guy, IC fixer. Oh, and then basically I have this problem in life. I just briefly describe just by voice or just typing. And then I delegate the agent acts on my behalf. What it does, it starts writing emails from my Gmail account, trying to compensate, repair, fix. Then, if there's no response, it automatically calls using the video API with the same. It generates call script automatically. It calls. It records their company response. Then it combines them together, and then it waits for tries to resolve the conflict so the customer is happy. In the idea, like I have this problem, I can just sit back, relax, and let the agent fight for me, and I'm going to enjoy my life and do something else. And all communication is done by the agent. It can go on Facebook auto post, which I was describing last summer. It can go to consumer advocacy site, Better Business Bureau, if it cannot resolve directly with the customer, and all the way till automated small claim court filing. So if nothing works, if nothing can do, if I try, for example, I cannot do credit card chargeback, I didn't pay for this credit card, or it's not relevant, then I have list of my active complaints, and system says that this one escalated, and then I specify whatever is not possible to extract from previous. System populates the form, small claim court form for me, collect evidence, and all the communication, all the calls, all the emails, it forms as evidence. And then for e-filing, it does e-filing. So basically, if I'm a new business and my customer is unhappy and customer have this tool, then it's better not to have a business, because it's a very efficient tool for customers. And the business model here is so now I'm a business. I have two choices. I have one choice, like ignore the system and experience full power, like it will call, email me, it will go to social profile, share unsuccessful, share something negative, all the way to dispute credit card payment and do small claims. So very hallucinations here. So the errors here are very costly and really look stupid. And the idea that I have to trust it. In Complaint Warrior, I have the option manual automated. I can review each email, or I can just say, let's just do it for me, automated, trusted, just do it for me. But for that, it shouldn't do hallucinate and shouldn't do stupid mistakes. So that is why like reasoning verification is that's domain where reasoning verification, because then basically it sends my emails, and if it's something totally, it can make some errors, but if it's like totally illogical, then I just wouldn't use it as a customer, because it's acting on my behalf and I have to trust that it does a reasonable job. Yeah, that's why hallucination. So behind the scene, it is important. Yes.
So an example here, keeping it in line is that
Okay.
respond with a reasonable satisfaction for the customer, but not, let's say, offer the $5,000 check for their, for their inconvenience or something like that.
Yeah, for example, like I have
Hallucinate something ridiculous that would be
like tax preparer is delayed. I cannot ask for 5,000. It has to be reasonable.
right. So that's the whole point is to get the bounds.
So these are not most of them. These are not something like focus full time and just resolving. These are like minor issues,
Right.
but I don't want system to make stupid mistakes.
Yeah,
and
you want
like,
to be able to trust the output and let it run.
again, I call to bank customer support. Not everything, the whole, not smoothly, and all CRM system are designed for me as a customer basically to switch to. So the whole idea of CRM is for me as a customer to give up. It makes so complicated for me to keep calling, keep switching. But this system, it does it automatically. And okay, company ignores my calls, company ignores my emails, it goes to smuggling core because I need to know, like something happened in different county. I don't know if this county accepts e-filing, but this system knows about different, like for California, then for California, it knows different counties, form is the same, it populates form, and it basically makes it easy for me, the whole process easy for me. Because most people don't go to smuggling course, just it's difficult and it takes time and unpredictable. And this is an expert, automated expert, which knows format, and it whatever it's missing, it will ask me in the form. Big question, more questions about this? But time-wise, I think good to
Yeah,
conclude.
and you're comfortable on time. There's no rush. You can stop now, go to 8:30, not much more than 8:45.
Well, I think maybe questions. I guess most important. I think the most important discussion we had on how reasoning works and how brittleness problem is solved. If you want to go back to that, and if you have more questions about that. Was it clear how logic works?
Other audience questions on anything at this time?
Like the text. Let me be even louder.
Yes.
Okay. Does put it up to the generative language model to come up with the ontology also?
Yeah, that's the main. Yeah, yes. So not just answer question, but also build ontology from
It builds new ontology, domain specific ontology.
Yes. Yes.
And it builds a lot of relations that it extracts from hearing,
Yes.
and then you turn it over to the
Reason.
solver.
Yeah. So simple question. LLM does everything other than just for me designing one good logic program, universal logic program, and running this whole thing. So running logical thing.
There's something called it's called narrative collapse or conversation collapse, where the subsequent calls to the LLM get stuck.
Yeah, we go get encoding meaning. Yeah, sometimes yeah, just stuck. Yeah. So okay. So in this case, it does stuck. When I keep asking, rebuild representation does work, rebuild, and then it basically repeats. Then it means we cannot verify. It means the logic isn't helpful because we cannot verify. So it happens, but in this case, again, just refuse to verify. Logic doesn't help. Okay, maybe I think we end here.
So when people were checking in, there was some door prizes, tickets given out. So we have a drawing for a shirt and a drawing for a cup. So if you take out your tickets, I'll draw out a ticket. You want to pull out a random ticket?
You read the last two numbers only, please.
Here, you help me out. You pull a ticket.
Oh, I got a 100.
Oh, okay.
What would you like? A shirt?
Okay.
I got nice. Nice.
99?
Yeah.
Unbelievable.
99. Does anybody have 99? Well, you get a cup. Thank you.
It needs washing.
All right.
It's got,
Thank you. Thank you for the door prize.
thank you for coming. By the way, we really could use some volunteers, especially someone who will help us acquire a bigger, better, more expensive door prizes to give away at our meetings. Really talk to me or Greg if you're available.
And to volunteer, your name doesn't have to be Greg. So thank you. And next meeting is going to be next month, and it's the Vision